So good morning, everyone. Am I audible? Anyone? Am I audible?
Yes, sir.
Okay, then. So today we are going to see another topic, that is compaction and then defragmentation. So in the last class, we learned that in dynamic partitioning, where we partition the memory dynamically, we may face external fragmentation. Okay, so this external fragmentation may be avoided by using different technique. So here we have one that we call it as part of this uh, excuse me. So we have this compaction. So what does compaction is? Compaction is a process in which the free space is collected in a large memory chunk to make some space available for the processes. Okay. So we know that when we have external fragmentation, we have different partitions that are being left out and cannot be used for any process since they are not in a contiguous manner, or they are not in a sequence manner. So to bring all those partition in a sequence or sequential manner, we may use this technique. So here, yeah, this compaction is trying to bring all those free memory partitions together. Okay, so it will bring the different free partition together, and this compaction is going to minimize the probability of external fragmentation. So here, as you have mentioned here, so all the free partition, okay, so all the so all the free partitions are made contiguous by using this compaction, and uh, they are loaded and brought together. So by this compaction, it brought the free partition into together. So then we have another technique that we call it as defragmentation. So the purpose of defragmentation is to divide the collected free partition into partition so that it can be allocated to the other process. So by defragmentation, we refer that it is a process, okay, that reduces the degree of fragmentation. So it does this by simply organizing the content of the mass storage device used to store files into the smallest number of contiguous regions, that is fragment or extent. So when compaction tries to bring all the free uh, partitions together, then defragmentation uh, will partition the collected chunk of what to say, a block of memory into different segment or partition again. Okay, so with the technique of this compaction and defragmentation, we can reduce to some extent uh, the problem of external fragmentation. So we have other technique also, like paging, we will discuss later. So this defragmentation is also one technique where we try to reduce the level of external fragmentation. So defragmentation reduces data access time and allows storage to be used more efficiently. Okay, so even our operating system usually have defragmentation tools or utility. Okay, some they can be done periodically automatically, and other where we may use the utility manually. Okay, so like it means that in some operating system we can run this defragmentation automatically, or we can do it manually as well. Okay, so here is what we refer compaction and defragmentation. Okay, then compaction and defragmentation is related to your solving this external fragmentation. So coming to this dynamic partition again, we know that whenever we have dynamic partitioning, we need to keep track of all the free and allocated partitions. Okay, so whenever we have free partitions, we try to bring it right. We try to bring it together by contraction, and we do the defragmentation. So the next question is, we need to keep track of all the free and allocated partitions of the memory. So how we are going to do? So operating system uses two data structure for this task, that is to keep track of all the free. So to track all the free and allocated partition, we use bitmap and we use linked list. Okay, so we may use this two data structure to track all the free and allocated partitions of the memory. Okay, so then the first one is bitmap. So how it's going to do is, here your main memory is going to be divided into a collection of allocation unit. So one or more units may be allocated to a process according to the need of the process. However, the size of the allocation units is fixed by the operating system and never changes. Although the partition size may vary, the allocation size is fixed. So when we use this bitmap data structure, here we're going to store all the information of our free and allocated partitions. So this bitmap is another data structure that is going to be connected with the memory, where it will store like which partition is free and which partition is going to be fixed, and it has to be fixed by the operating system. Okay, just a second. So even though the partition size may vary as we are talking about dynamic partitioning, but the size of this bitmap is going to be a fixed one. Okay, so we have this data structure bitmap, then we have another one that is linked list. So I think everyone is familiar with linked list data structure. As before, we know that it's going to contain in the form of arrays, right? We are going to have sections where we are going to store information. So this one, we have bitmap data structure, then we have this another linked list. So this linked list form better and the most popular approach to keep track of all the free or filled partition. So in linked list, how we are going to do is, as we know, everyone knows what is a linked list, so we're going to just store the information in that linked list. Okay, so how the operating system is going to maintain the information of the fill or the free partition in the linked list is, here we are going to have some information, that is we're going to have three fields. So it will maintain, and that operating system will maintain a linked list where each node represent is partition. Okay, so here every node represent is partition. So it's node represent is partition. So, and every node is going to have three fields. The first one to show whether the partition is all or some process is free. So you may find the term like whole. So when we say whole, it means that the partition is free and no process is being there in that partition, and it's available for use by any process. And the second field is going to store the starting index of the partition, and the third field is going to store the end index of the partition. Okay, so in this linked list, we are going to have this information of whether the partition is free or whether it is being occupied by some other process. Second, you're going to have the starting index of the partition. The third, the end index of the partition. Okay, so if a partition is free at some point of time, then the partition will be merged with its adjacent free partition without any extra effort. Okay, so whenever there is free partition, it's going to be merged with its adjacent free partition. So the first we discussed is about defragmentation. Then we have these two data structure, bitmap and linked list. Okay, now we will come out how the partition algorithms works. We have few types of algorithms. Just see it. So here is few partition algorithms. Okay. So these there are various algorithms which are implemented by the operating system in order to find out the holes in the linked list and allocate them to the process. So when we say to find out the holes, we refer to find out the partitions. To find out the partitions. So to find out the partitions where the partition is not being used and it is being free, so that another process can use it. So we have different algorithm on this. The first one is, we call it as fast fit algorithm. Okay. So as the name suggests, fast fit algorithm. So we know that in a linked list we have to scan, right? So in the linked list, it will have the information whether the memory is free or the memory is being used by other process. So whenever we have this free memory, then we have to check whether the free memory is capable of allocating to the new process that requests for it. So as the name suggests, fast fit algorithm, it's going to just check whether from the beginning it start scanning the linked list, and it has to check the fast partition where it can allocate the request of the process. Okay, so what does it say? So this fast fit algorithm scan the linked list, and whenever it finds the fast big enough hole refers to free partition to store a process, it is stop scanning and load the process into that hole, meaning that whenever we find a partition that is big enough to give the partition to a process, we give the partition to that particular process and we stop the scanning of the memory. Okay, So this procedure produces two partition. Out of them, one partition will be a whole, while the other partition will store the process. So then your fast fit algorithm maintains the linked list according to the increasing order of the starting index. So just like we know that linked list, we have to scan from left to right, and in that manner, we will be scanning from left to right, and whenever we find the fast big enough partition to give the process, then we allocate that partition to the process. Then the next algorithm is, we call it as next fit algorithm. Okay, so next fit algorithm is similar to the first one, that is fast fit algorithm, except that here we need not to scan everything from the start. Okay, so in fast fit we start scanning from the fast and keeps going on, but in next fit algorithm it's also similar to fast fit, except the fact that we have to start scanning uh, from the point where it is previously allocated. So like if we have allocated a process in the say in the position 3, when we talk about next fit algorithm, then we have to continue from that point of from that part of the memory. Okay, so so next fit algorithm is similar to the fast fit algorithm, except that the fact that it scans the linked list from the nodes where it is previously located a hole. Okay, so it doesn't, when we are talking about next fit, it doesn't scan the whole list. It start scanning the list from the next node. Okay, and here are a few things, that is your next fit is not better than the fast fit. Okay, then the next algorithm is, which we call it as best fit algorithm. Okay, so the best fit algorithm tries to find out the smallest hole possible in the list that can accommodate the size requirement of the process. So when we're talking about best fit, it also starts scanning from the fast and till the end. For best fit, it has to be scanning till the end, and it has to find the partition which has the least size that is possible to give the memory to the process. Okay, even though the name is best fit, but it doesn't always give the best results. Okay, so few disadvantage may be like your best fit is a slower algorithm, as it scans the entire list every time and tries to find the smallest hole which can satisfy the requirement of the process. So we have to scan the entire linked list every time. So it is a slower process. So, and the next thing is that despite the name that it is the best fit, it doesn't give the best result always. Okay. So so the next algorithm is, okay, just a second. Okay, so the next algorithm is worst fit algorithm. So it's just the opposite of the what to say, best fit. So in the best fit, we try to find the smallest, but in worst fit, we try to find the biggest partition. So it scans the entire list every time and tries to find out the biggest hole in the list, which can fulfill the requirement of the process. So here also same thing, it scans the whole linked list and it will pick out the partition which has the highest or the biggest size and that can hold the process. Okay, even here also it will be slower as it has to be scanned the entire list every time again and again. Okay, worst fit and best fit, the way of working is same, only the selection of smallest and the biggest is the different. Then we have this quick fit algorithm. Okay, in this quick fit algorithm, uh, so in this quick fit algorithm here we have to maintain two different linked lists. Okay, we have to maintain another linked list for the frequently used sizes of partitions. Okay, so it suggests maintaining the different list of frequently used sizes. So even though it is practically suggestible, because it is not practically suggestible. Okay, like it is practically difficult to implement, as maintaining two different linked lists would be a problem. Okay. So the notes we can take from this few algorithm is that the first fit algorithm is the best algorithm among all those distinct, all these 5 algorithms. So the points may be that it takes less time, it takes less time, then it produces bigger hole that can allocate the process later on. So if when we say fast fit, we try to get the first smallest one, so it will left the bigger holes for the other process, and it is easy to implement. Okay, so these are all about the partitioning algorithms. Okay, so okay, so that's it for today. And if you have any doubt about today, or if you have doubt about left exam, you can tell me.
Sir,
uh,
sir, regarding the lab exam, we have this Viva portion, which I don't know whether we will be having it today or after our final exam along with the theoretical part. Can you just specify on that?
okay, for Viva I won't be taking it today. I'll take it with the theory also. Theory also we're going to have Viva, right? So
Yes, sir.
I'll take it together at that time.
Mm.
Okay, thank you, sir.
Okay. So if you don't have any question, you can just leave your attendance in the chat box, and all the best for the exam.